let's think about combining the concepts of isoquants and isocost in order to think about cost minimization. So this is really important in healthcare because it's addressing the ideas of whether we can produce healthcare at a lower cost by changing the way we produce. So let's just think about our story that had antidepressants and therapy. And let's draw some isoquant that was depicting the various combinations of the two inputs that could produce care for the patient. So let's think about some points here. Now we can give them numbers. Sometimes that's helpful. Let's make these look like this, and it is curved. So let's say this is 2. Let's change that from 5 to make this a little easier. This is 2. Maybe that's 3, but this is 5, and maybe this is 8. I want it steeper to the upper left and then getting flatter towards the bottom right in order to really show that it's a curved shape. Okay, so now we also knew about isocost, so let's put in the possibility of isocost, and it is describing a line always that represents our total cost that we have given to input prices. So, for example, let's think about this as my isocost. If this represents my isocost, then I can see that point B is the only method that I'm able to produce the patient with that level of total cost. All the other choices on the isoquant are outside the boundary of the isocost. Now, I can spend at other points also. I can spend the same total cost over here, but then I'm not able to reach the isoquant in order to serve one patient. And I can spend the same amount over here, but I'm also not able to reach that isoquant. So where it's tangent is the only place where I produce, in this case, one patient, and that means it is the minimum possible cost in order to produce one patient. Now I can still do that production with more money. So for example, if I did point A, point A is a possible means to produce, but as we learned from the isocost video, and higher isocost is greater total cost. So this means that when we're not producing at an allocatively efficient level, we are producing at a technically efficient level at point A. So technical efficiency means we're using all the inputs in a combination that produces an output. So every point on our isoquant is technically efficient because I'm not basically throwing away resources when I'm producing there. So for example, when I use 3 antidepressants and 3 therapy visits to produce at point C, I'm using them all up and I'm serving a patient. Allocatively efficient means I'm taking into account the prices and making a production choice that will be at lowest cost. So by producing at A, I am technically efficient because I'm using up all the 8 therapy visits and using the antidepressant, but I'm not allocatively efficient because I'm using too many therapy visits as compared to antidepressants according to the cost of each of those inputs. Therefore, the only cost minimizing point with this kind of scenario is point B. There's one final option where what is currently the cost minimizing point of B can change. And only thing that can change it is if the input prices change. So if antidepressants go up in price, what that does to an isocost is that it's going to make it steeper. And if the isocost gets steeper, then we could end up that with our given total cost, we can't afford so many antidepressants anymore. And so if our total cost that we had is the same, but the antidepressants got more expensive, then that's going to rotate our isocost. And the one I've actually shown here is it got steeper because there is a higher price of an antidepressant, but it can only reach all the way up here is if the therapy also got cheaper. So let's say therapy goes down in price. One reason therapy could go down in price might be through some kind of telemedicine. And so those two together have moved my isocost. And now you notice that it's better in this case from a efficiency standpoint to go for 8 units of therapy and 3 units of antidepressant. And so this would be the new cost minimizing way to produce.